Hello, my name is Dong Wook Yang. Today I am going to explain quantum cascade laser as a YouTube project for MS310 quantum chemistry for materials scientists. I'll explain it to make it easier for beginners to understand. So please follow me well. First, let's talk about what is quantum cascade laser. The name may remind you of the waterfall shooting a laser, but it's not the answer. However, the reason why it was named Cascade is that the active layer inside has a multi-stage energy band like the Cascade waterfall flowing in multi-stage. I will talk more deeply about active layer later. Then, is it a type of conventional p-n semiconductor laser? But it's not the answer again. Quantum cascade laser is a unipolar semiconductor laser that uses light-emitting electron transitions between soft bands formed during multi-quantum protocols, and only electrons appear as a carrier. Therefore, the recombination of the whole electron pair is different from conventional p-n semiconductor lasers, which are the causes of laser oscillation. Then, what is the quantum cascade laser? First of all, the quantum cascade laser looks like this. You won't know what it is just by looking at it. Then let's find out about quantum cascade laser one by one from now on. First, the quantum cascade laser is a new laser that is in the spotlight because it has three main advantages. First, the oscillation wavelength is not limited to the band gap of the material, and it can be designed from the medium infrared rays of the same material to the terahertz band. Second, a plurality of photons may be emitted per injection electron using cascade coupling. Therefore, it can be used where high power operations is required. Third, due to the ultra-high-speed non-emission mitigation process, the width of the oscillation spectrum is essentially narrow. First, it is necessary to know the resonance tunnel effect before learning the principle of quantum cascade laser. The resonance tunnel effect is a phenomenon in which electrons with a certain energy escape an area called a quantum well surrounded by two very close potentials as if there were no barriers. This is because the material waves of electrons that exist one barrier become static waves between the barriers, resonating with the electromagnetic waves from behind and becoming strong. In short, it can be seen as quantum tunneling at two adjacent potentials. The main structure of the quantum cascade laser is called an active layer. As mentioned earlier, if you look at the active layer, you can see that a multi-stage energy band like Cascade waterfall is connected. The active layer can be viewed by dividing it into an injector region and an active region. First, as can be seen from the figure, the injector region has a sharp superlattice structure that gradually decreases from left to right. And the other point is when the voltage is applied, the miniband in the superlattice becomes flat. Now, let's follow the electrons directly and see what happens in each region by dividing it into 5 steps. The electrons are represented in a red circle. Step 1. Let's say the voltage is applied to the element first. Then, electron is injected into the miniband of the E3 energy level of the injector regions as follows. Step 2. The electron entering in this way moves through the superlattice of the injector region to the E3 energy level in the active region by the resonance tunnel effect described above. Step 3. the electron in the E3 energy level now fall to the E2 energy level, and this time one phonon is emitted. Step 4. Next, the E2 energy level is unstable and electron move to the E1 energy level by the mitigation process. Step 5. Finally move from the E1 energy level to the next injector region. 5 steps are required for the injected electron to emit one phonon. Now, let's go here. The important thing is that the electron continues to cross over the closely connected active layer and repeat 5 steps. Thus, as we have mentioned earlier, one electron may emit a plurality of phonons. So far, we have been able to learn the principles of quantum cascade laser. Then, let's check what future the quantum cascade laser has. Quantum cascade laser can be used in various fields, among which many studies are being conducted as it is used in gas sensing. It is also used in the field of medical diagnosis and is being studied to play many roles such as breast analysis, biofluid screening, and analysis of body fluids. So far, I have explained quantum cascade laser. I hope you understood well, and I will end up the video here. Thank you for watching. Please click like and subscribe.